Good morning. Today we are in section 2.7, which is combining like terms. This is a concept that you did learn in middle school, but it has been a while since we've done it, so we want to refresh your memories before we get started into using this skill throughout equations and throughout this whole year, really. A coefficient. A coefficient is the number that is being multiplied by a variable. And I just want to stress that it's not the variable itself, it's just the number that's being multiplied by a variable. So for example, if you see 2x, that 2x means that I'm taking 2 times our x. It's implied that those two things are being multiplied because there's no other operation between there. So we would say that 2 is the coefficient of x. It is the number that's being multiplied by that variable. Now, there will be times, and I've got a negative x here. You could also just see a positive x. If there's not a number in front of the variable, it's implied that it's a 1x. In this case, a negative 1x. So looking at that number that's in front of that variable. Now, if you take a look, this also has a plus 5 with it. Plus 5 is our constant. A 5 is just a constant. It does not have a variable. It's not ever changing. So that would never be considered a coefficient. 5 would be a constant. The coefficient here is the coefficient of the variable, the number that's multiplied by that variable, the negative 1. Now, another vocabulary term, like terms. These are terms that have the same variables taken to the same power. I have an example on here. We have 4x squared y cubed and 2x squared y cubed. Those would be considered like terms because they have the same variables taken to the same power, that x squared y cubed. Most frequently, you'll see things like 2x and 5x. Those would be considered like terms because they both have the exact same variable taken to the same power. In this case, they're both just an x to the first power. A simplified expression will be an expression where there are no more grouping symbols, so no parentheses, no brackets, and all like terms have been combined. And we're going to talk about doing that in just a moment. This next problem, or this first example, says that we're going to identify the terms. We've got several parts here. Identify the terms, the coefficients, and the like terms. Now, terms itself was not one of our vocabulary words, but I just want to emphasize what that is. When we're looking at terms, we're looking at the pieces that are being added or subtracted. I'm just going to put a little note, and you guys might want to add this to your papers too. So the things that are being added or subtracted. So for example, 5x is a term. A 6 is a term. Be careful because the sign in front of the term will stay with that term. This is actually going to be a negative 3y, a 2x, a negative 4x, and a 7. So we have several terms here. Now, the coefficients, again, those are the numbers that are being multiplied by the variables. So coefficients in this problem, I see that 5 is a coefficient of x. A negative 3 is the coefficient of y. A 2 is another coefficient of x. A negative 4 is another coefficient of x. So we have several coefficients of x. This negative 3 is actually one of the coefficients of the y value. The rest of them are all x's. Now when we talk about like terms again are going to be those pieces that have the same variable taken to the same power. So as you look at this problem, I hope you guys notice that there's several things here that all have x's. Those would all be considered like terms. So when we combine them, we've got 5x plus 2x, that would be 7x's so far, and then minus the 4x. That would leave us with 3x if I would be to combine them. Now they just ask what they are. So I'm going to go ahead and say 5x, 2x, and negative 4x are all like terms. I also have some other like terms. I don't have any other y's to combine my negative 3y with, but if you look at the constants, constants can also be like terms with one another. So our 6 and our 7 are also considered like terms. Let's try that whole process again. I want you guys to do this on your own first, and if my sub could go ahead and just hit pause for a minute. And once they try it on their own, then we're going to go ahead and hit play and listen to me talk through this. All right, the terms here would be the 3x squared, the 4, the negative 6x, the x squared, and the 1. Those are all the terms. Those are each of the pieces that are being added or subtracted. Coefficients here, we had 3 was a coefficient of the x squared term. A negative 6 was the coefficient of the x. And if you guys notice, this one didn't have a number in front of the variable. So that's when it's implied that it's just a 1. I just want to clarify that we're talking about this is our 1. This 1 is a constant at the end. So that is not going to be a coefficient because it does not have a variable with it. Like term, and again, 4 is the same way. 4 is not a coefficient because it doesn't have a variable with it either. When we talk about the like terms here, the like terms are things that have the same variable taken to the same power. So notice that I had an x squared here, and I have an x squared here, and then I have an x. This x, this negative 6x, is not a like term with the x squareds because it does still have the x, but it's not also taken to the same power. So 3x squared and 1x squared, or just x squared, would be considered like terms. And then our 4 and our 1 are considered like terms. This negative 6x is just all by itself. It does not have a like term to join with it. Same process. Go ahead and try this one on your own first. Hit pause, and then once we're ready, go ahead and hit play. The terms here, we have a negative 3x squared, a 2x, an x squared, a negative 4, and a 7x. Those are each of my terms. The coefficients are going to be the numbers that are being multiplied by the variables. So looking, we've got a negative 3 in front of the x squared, a 2 in front of our x. Again, here's that imaginary 1. That's not really imaginary. It's there. We just don't write it. So a 1. I don't touch the negative 4 because the negative 4 is a constant. And then our 7 is the last coefficient of x. Notice that when we list the coefficients, these pieces don't have variables with them. When we list terms, they do, because the term's talking about the entire piece that's being added or subtracted, where the coefficient is just the number that's being multiplied by that variable. Now, when we say the like terms, looking at this one, I do have some x squareds. I have a negative 3x squared, and I also have a positive x squared or a 1x squared. Either way you want to write it is fine. And on this one, I do have a 2x, but I also have a 7x. Those are also considered like terms. Notice that this negative 4 that I haven't really done anything with, it's a constant, but there are no other constants, so it's not a like term with something else. Okay, we're going to be focusing now on simplifying the expressions. And when we simplify, we're going to be combining the like terms together. When you think about this, if I had said, and I'm just going to say in case we're not comfortable with the x's, if I had said I had 8 apples and 3 more apples, you're putting those together to say how many total apples do you have? And that would be a total of 11 apples. Same idea here. When I have 8 x's and 3 more x's, altogether I have 11 x's. So when we're combining like terms, we're adding the coefficients. The variable stays the same. Notice that they have to be like terms first. So as long as they're like terms, you're going to add the coefficients and the variable part will stay the same. All right, knowing that now, let's take a look at this next example. Notice that I have several pieces that have x squareds with them. Because they have x squareds, they're like terms with each other. So if I look at this one, I had 2x squareds plus 7x squareds. So right now, I'm looking at 9x squareds. But then I'm taking away 1x squared. If it helps see that, that's fine. So I had 9x squareds minus a 1x squared is going to leave us with a total of an 8x squared. So think about just the numbers. I had a 2 plus a 7 minus a 1. They're like terms, so we're going to combine them together. Now, notice that I didn't use this plus 2. This plus 2 at the end is a constant. It's not a like term with the other terms in this expression. So when it's not a like term with anything else, we'll just bring it on down. So we had 8x squareds plus 2. For this next example, notice that I do have some y's, and I have some y squareds, and I have some constants. I want you guys to think about this on your own for me. Sub, go ahead and hit pause, and then we'll go look at it in just a second. Okay, so if we combine the y's, those are like terms together, we're going to have a total of 3 y's. I had negative 3 plus 6 would give me a positive 3y. Then I can look at combining those constants together. I have 4 positives and 2 negatives. That would give me a positive 2. And that y squared is not a like term with anything else, so we just tack it on. Now, we will eventually get to the point where we're going to be really focusing on leaving these things in what we call standard form. And standard form will be when we leave these pieces in order from the largest exponent to the smallest exponent. So this would be when I would say a y squared, then a 3y, and then a 2. I'm not going to stress that you guys have it in standard form right now, but I wanted to say that just to get you guys to realize that when you're looking at terms, terms can be rewritten in any order as long as the sign in front of them will stay with them. This right back here was a positive y squared. I still have a positive y squared. It's just written in a different order. And with addition, the order won't matter, so that's okay. All right, guys, the rest of the class period, you need to be working on your homework. It's section 2.7, combining like terms.